Anglo-Saxons. If you're familiar with both, you may understand what I'm talking about. So French are great at beauty, and Paris is just, you know, a wonderfully beautiful city. It's the world's most popular tourist city. Right? I don't know if you knew that. More people go to Paris than anywhere else in the world because it's just so beautiful. The French are really into that stuff. And despite appearances, you know, appearance being often more important than the substance, the French are great mathematicians. Right? They've won a lot of the Fields medals. It's mathematics, a very strong tradition in French culture. But I personally, when I like to learn something, the completeness and thoroughness and all that can come later. But when I'm trying to actually learn something, I'm trying to pick up the concepts, I hugely prefer the Anglo-Saxon approach to the French approach. The French sort of very thorough from the beginning, often, you know, it's the tendency. And I personally, and I think a lot of people who are neither Americans, neither French, would agree with that. When you're learning something, didactics, you know, the principles of efficient learning are more important than thoroughness at the beginning. Anyway, all right. So for reasons of simplicity, our finite automaton, once it's finished its processing, it will give a decision, and to keep it simple, that decision will be only of two types: accept or reject. And we don't yet know what that means. Accept or reject what? Well, you're probably suspicious it's got something to do with the input string, right? It accepts that string or it rejects that string. But what is it about the string, you know, of symbols that come in that it's accepting or rejecting? Well, yeah, I will not give you the answer to that yet. I'm just posing the question. But you may be getting suspicious that accepting or rejecting the string is part of the function of the automaton. It's performing some job, some task, right, of deciding whether a particular string is to be accepted or rejected according to some criterion. Aha! You know, you can just deduce that, right? It's just almost common sense if you're curious. All right. Okay. All right. So we will restrict the decision of the automaton after it has processed the input string, you know, a string of symbols, presumably from some allowed alphabet. Right? Remember, in the previous chapter we talked about an alphabet. It's just a set of allowed symbols, and a string is constructed. You know, it's a sequence of the symbols from a particular alphabet. Okay. Now, in the previous square we had just an input sequence string was just 1101. Okay. So the alphabet there would just be the binary alphabet, which is just, you know, just only two possible symbols in that alphabet. It's just 0 and 1. Okay. All right. So let's now this automaton here. Let's label it M1. M for machine, if you like, and it's our first example, first real example. So we'll just call it M1. Right? And so this label M1 labels this automaton, right? This state diagram. Everything is here in a sense, right? You know all possible states. Implicitly, you can deduce all possible state transition rules. So you could, from this diagram, construct the state transition table. Right? It's all there. Okay. So in a sense, this is the complete automaton, right? So we'll just label it M1. It's the complete automaton. So this automaton is M1. All right. Now any automaton has to start in a certain state, right? So this machine M1, this automaton M1, will start in some start state. Right? In this case it's Q1. We know that because of this arrow here. Right? And this automaton receives a string of symbols, right? From some alphabet. Okay? And these a string of symbols, and the symbols one by one, each symbol one by one, is obtained from the input string. So you can imagine this as a black box, M1 if you like, and into this automaton, this machine, this M1, goes a string of symbols. Right? And the automaton reads, in a sense, looks at, examines each symbol in the string one by one. Okay? And when it's finished looking at all the symbols, when it's looked at the whole string, it then makes a decision. And its output is one of those two possible decisions: accept or reject. And it will accept if the string is of a certain kind, and it will reject if that string is not of a certain kind. Now I'm starting to be a bit more specific about the job, the function of an automaton, right? Okay, now a bit more detail. So this automaton is reading individually, one after the other, in time, a sequence of symbols from your input string. Now, as it reads each symbol, it will make state transitions. Right? So your automaton M1, it'll start in the start state. In this case, Q1. It'll start here. It will read the first symbol in the string, and depending on what that symbol is, it will make a state transition. It will switch to another state, depending on, well, as we talked about before, on two things: the current state, well in this case it's Q1, the start state, and what the input signal is. What the input symbol, the first symbol in your input string. Okay. Now, well, let's say so it's in start state Q1, and let's say the first symbol in the string is 0. So the input symbol is 0, and so this state diagram tells you that the next state is Q1. Because this transition is back to itself, right? So if the input signal, the first symbol in your string, is 0, then the transition is back to itself, so it just stays here. Okay. But say the first symbol in your input string is a 1. So if the current state is Q1 and the input signal is 1, then the next state is Q2. Okay. And now here's a concrete example of an input string. Remember, you read the input string from left to right. Okay, so it'll be 1, 1, 0, 1. So let's actually do this. Let's input this string here to this automaton M1, this one, and let's see what happens. Okay. So we will see whether, for this particular string of 1, 1, 0, 1, will this automaton M1, with this state diagram, the state diagram specifies the automaton, right? Because it's all there. So will this machine M1, will this automaton, will it accept or reject this string? Now I need to give you a few more details. When does an automaton accept, under what conditions does it accept a string? Well, the answer is after it has read the last symbol in your string. Okay, after. If its state, its current state, after having read the whole string, it's looked at every symbol in sequence, one after the other, if the state that it's in then, after having read the string, if that is not one of the accept states, now in this case, this is a very simple automaton, there's only one accept state. There's only one state with two circles, so to speak. So if in a sense your final state, the last current state, if that state is not an accept state, then the automaton will give a decision reject. Okay? And if that